concept of this probability, but I am giving a different way. That is very important one. What is sample space? In the beginning, in the last class, already I explained the exhaustive cases. According to classical probability theory, associated random experiment, exhaustive cases explained. Now, based on the axiomatic approach for the same random experiments, to apply the statements, inequalities, advanced to different techniques, you have to learn the sample space. The sample space served as universal set. Universal set is a term of the set theory. But in this paper, we have to take some set theory techniques and advanced techniques. Basic techniques, advanced techniques, both are required to apply required to solve the probability problems. In basic level, we learn set theory techniques, but in advanced level, we have to take the class of sets. The class of sets is very important one. To learn the measure theory, the class of set is very important. I will give the complete information. After this sample space. The sample space means set of all possible outcomes. Set of all possible outcomes of a given random experiment. Totality of all possible outcomes. Totality is a powerful word. Totality of all possible outcomes of a random experiment constitutes sample space. Simply we can say that set of all possible outcomes of a given random experiment is also called exhaustive cases. Initially, by taking the classical definition of probability, you have to take the term exhaustive cases. By axiomatic approach, to define the probability functions, definitely we have to take the sample space. But initially both are same. In advanced level, the sample space is different from exhaustive cases. The set of all possible outcomes of a given random experiment. Each possible outcome or element in a sample space, what is called sample points, or an elementary event, singleton element is called elementary event. The size of the sample space denoted by n of s. How can measure the size? How can measure the size? According to the sampling theory, that size is very, very important. There is a small n and Kaplan here. To learn what is the difference between small and Kaplan, according to sampling theory techniques, definitely first of all you have to know the sample space. The number of sample points in the sample space S are denoted by n of s. That is very important. So this is a basic concept. One more definition for this case. Totality. Totality of all possible outcomes of a random experiment. constitute the sample space. In ISS examination point of paper 1, some bits from theory. To answer all these questions, to get the full marks for this one, 2.5 marks, there is evidence here. There are 4 options are there. Statement level, statement 1, 2, 3, 4 like this. Which statement is true? How many statements are true? Here is that is very important here. Some false statements are there, true statements are there. If you know the concept thoroughly, definitely you can choose the best option. I prepared a lot of problems only based on these concepts. One of my professor prepared this all these questions for ISS students here. I will share all these bits to the students who are preparing for these examinations. A lot of problems are there. For each and every topic here, lot of models are available. You have to prepare, practice as many as problems. For paper 1 and paper 2, here refer the fundamentals of mathematical statistics. We are also referring that book. I will solve as many as problems. For exercise problems, for solved examples, you have to refer the book, go through all solved examples. We will conduct the examinations based on that models. But in classroom sessions, I will take the exercise problems, as many as problems, which are feasible to our examinations. Out of this, here 100 problems, whatever here 100, 200 like this year, only 60 to 70% problems are feasible to the ISS examinations. The paper 1 or paper 2. Total possible outcomes of totality of this word is highlighted. You have to prepare the notes and use the highlighter. So highlight these points here. Before examination, you have to read out all these one. Total possible outcomes of a random experiment constitute sample space. Remarks. Some important remarks are there. First remark. The sample space serves as universal set. For all the questions. For all the questions concerned with the experiment. Sample space serve as universal set for all the questions concerned with the experiment. Number 2. A sample space is said to be finite or infinite. Finite, infinite, sample space. To solve the problem, read the problem carefully, identify the sample space. That is very, very important. There is a problem to identify this one. Some of the students are facing the problems to identify the sample space. If you know identify the sample space, actually new problem is there. Some questions is a very frequently asked models are there. No doubt about these problems. For new problem, first of all, you identify the sample space. The sample space may be finite or infinite. What is finite here? The number of elements is finite. Number of elements is finite. Infinite means infinite. Example, suitable example. A coin is tossed at a time. That is random experiment. The total possible outcomes of this random experiment. This is random experiment. The sample space will be total possible outcomes of this experiment is only head and tail. Is a finite case. Finite sample space. Here is another example. Same experiment. A coin is tossed until head appears. Head appears. Now the sample space is very important concept. Until is a very important word. The word indicates this type of variable follows geometric progression. The variable in the geometric progression, the sequence. Here, the outcomes are what? The sample space contains. The head may occur at first time. The head may occur second time, third time like this. TH, TT, H, and so on. No endless. This is infinite sample space. Infinite sample space. Next, third one. A sample space is called discrete. Is called discrete if it contains only finite finitely or infinitely many points. Finitely or infinitely many points, which can be arranged into a simple sequence. Remember this point. Simple sequence x1, x2, x3, and so on. About two examples are discrete sample space. First example, coin is tossed at a time. Example one is a finite discrete sample space. Discrete sample space. Second one is infinite discrete sample space. To solve the problem, examination problem, definitely have to use these techniques. But there is no continuous sample space in our syllabus. Strictly, we have to take the only discrete sample space. Remember this point. No continuous sample space. Non-denumerable points. The sample space containing non-denumerable number of points is called a continuous sample space. In the prescribed syllabus, there is no non-denumerable points in the sample space. But actually, this is a very high concept, but no need to take this one. But throughout this syllabus papers here, strictly we have to take the discrete sample spaces, many cases. So this is the importance of the sample space. Now, some illustrations. Illustrations are very, very important. Before taking the illustrations, some sample space conditions are there. Properties. Properties of sample space. These properties are very, very important. Property 1. Each element of S means sample space, denotes a possible outcome of the experiment. Possible outcome of the random experiment. Random experiment abbreviated as RE. Second property. Any trial results in an outcome that corresponds to one and only one element of the S. Set S. So here I am briefing this definitions here. Shortened. Actually, different types of notations and different types of statements are also included here. For easy understanding, for referring, these notes will be very useful to solve the problems. These are the two properties. The set S. S is called a Serodance universal set associated with an random experiment, real or conceptual, satisfying the above two properties is called the sample space of the experiment. In the subsequent chapters in random variable, mathematical expectations and distributions, for understanding the problem, what is the sample space, how can find out this one, some situations to identify this sample space is very typical. By learning all these properties, easily we can identify the sample space. Once you have to identify the sample space, automatically you have to take the favorable cases. What is the requirement? Based on the requirement, how many cases are favorable to our desired event? Our desired event is maybe even number, odd number, prime number, like this here. To understand all these concepts of this sample space, so we have to take some illustrations. These are very, very important here. Some illustrations of the sample space. A simple one, starting with first here, a coin. A coin is tossed at a time. The sample space, now use the set builder form. The N of S, total sample points. These are also exhaustive cases. Exhaustive cases. Number 2. A coin is tossed two times, or one coin is tossed two coins are tossed at a time. The sample space will be HH, HT, TH, TT. These are hypothetical figures, hypothetical population. Number of sample points in the sample space, 4, 2 square. Another is one. A coin is tossed n times, or n coins are tossed at a time. Both are random experiments. Total possible outcomes of these random experiments. The sample space contains the size of the sample space for this experiment. N of S is equal to 2 power n. Now 2 is what here? What is 2 here? Head or tail? What is n? Number of, in one aspect, this is number of trials. In other aspects, this is number of coins. There is no difference here. This actually generate like this some of the binomial quotients. NC naught NC1, NC2, and so on, NCN. That is equal to 2 power n. Some of the binomial quotients. Here is 0, 1, 2, 3, and so on n. No head, 1 head, 2 heads, n heads. Total possible outcomes. Out of these n times, n times here. No head, 1 head, 2 heads, n heads. Any one is possible here. No head is possible, 1 head is possible, 2 heads are possible, 3 heads are possible. All n heads are possible. The head is same as tail. This is a very important information. Next one. The meeting will be ended within 9 minutes here. Immediately have to join again. There is a 40 minutes limitation for Zoom here. That is the problem. After 9 minutes, you have to join again. A die is thrown at a time. The sample space will be 1, 2, 3, 4, 5, 6. N of S is equal to 6. A finite sample space, discrete sample space. Remember this one. Sample space is finite and discrete sample space. A die is thrown twice or 2 dice are thrown at a time. The sample space contains 1, 2, 3, 4, 5, 6. Now 1, 2, 3, 4, 5, 6. This will create order pace. By using the set theory notations and relations, this will create order pace. Now, the sample space contains 1, 1, 1, 2, 1, 3, 1, 4, like this, and so on. Here is, and so on, 6, 1, 6, 2, and so on, 6, 6. N of S, 6 into 6, 6 square, that is 36. Total possible outcomes of this random experiment, 36 different points are there. Here 1, 1 different from, so 1, 2 is different from 2, 1. In the order pair, the first one represents number on the first die. Second one represents number on the second die. Now, so here is give the importance to order. 1, is 2 different from 2, 1. 1, 3 is different from 3, 1. The complete the sample space contains 36 points. In general, a die is thrown n times, or n dice are thrown at a time. N of S is equal to 6 power n. Now 6 is what here? outcomes of the random experiment. Here n is number of dice. One more aspect. Number of trials. You remember here, the number of dice are independent. By throwing the dice are independent. Number of trials are independent. The die 1 is not depends on die 2. Die 2 is not depends on die 1. You remember this point here. It's very important one. Next, another example. A coin and die are thrown at a time. A coin and die throw at a time. The sample space contains 12 points. 1, 2, 3, 4, 5, 6. Now, the sample space contains 12 points. 2 into 6. That is n of s. The complete sample space looks like this. Order pace. This will also create the order pace. H comma 1, H comma 2, head comma 2. And so on, head comma 6, tail comma 1, tail comma 2, and so on, tail comma 6. Total points is 12. 2 into 6. 12 cases are there. Out of these 12 cases, how many cases are favorable to our desired event? Help of the simple mathematical definition of probability, easily we can solve the problems. If you can thorough all these points, definitely will get the result of the given examination problems. Topic by topic, chapter by chapter. So we have to know the weightage. Once you know these concepts, so this is the basic concepts for all chapters. All remaining chapters, statistical methods, statistical inference, linear models. In paper 3 topics and paper 4 topics, some of the topics also depends upon these basic concepts. So that's why I am taking the much more time to explain all these topics. You remember that one here. But nowadays, so some of the students are not interested to take this theoretical part. They want to directly solve the problems here. But solvation of problem is a different process here. To solve the problem here, you have to timely remember the technique, which technique to be applied here. There is a mixture questions are there here in the examination. Some questions are very lengthy. Some questions are very shortened. Some questions are based on logical theory. But using all these techniques, some questions in the examination point of view, you have to leave or discard some questions out of 80 questions, out of paper 1, paper 2, out of questions, you have to 10% questions will be weeded out. Left the 10% questions. 8 to 10 questions will be left out. All these 10 questions are very different types of questions. But all students can solve those problems. All 10 questions are very easiest questions. All students can solve the problems, but actually each question takes more than 5 to 10 minutes. There is no shortcuts. You have to concentrate the remaining 72 questions. I will try to reduce that number also. Based on the last 20-22 paper, so 8 to 10 questions are very lengthy questions are there. Actually, those questions are theoretical questions, descriptive type questions. By applying the more integrations, double integrations, by applying that this one. If you have a time, so in that time you have to solve this. Either 1 or 2 questions will be get the answers here. In the beginning, though, no need to attempt those type of questions. I will give the planning. How to start the examination, which question to be answered first, which question to be answered second, which question to be answered third, like that. Don't take the pattern like this from 1 to 80 questions. How much time to spend the probability concepts? How much time to spend this? Okay. Now continue the class. So these are the suitable examples. Illustrations of this sample space. Now here is another one. That is 8th one. Four cards are drawn. Please mute. I request to all students, please mute. Four cards are drawn from the pack. Pack of playing cards. First of all, you have to know the complete description about these packs. Actually, out of 192 countries, 180 countries using the 52 cards system. Spanish cards. Spanish pack contains 72 cards, but literature based on the only 52. So don't bother about this 72. Now, a pack consists of, I will give a brief description about these packs. You know very well, but I am giving the different way. A pack has 52 cards. There are 4 suits. 4 suits. Suit means color. Suit means color. Type of pack. That is a diamond. Diamond is a suit. Heart is a suit. Spade. That is called spade. Club is a suit. Here we have to use the technical names. Diamond, heart, spade, club. Each suit consists of 13 calls. All are equal likely cases. The probability of getting diamond, heart, spade, club when a card is drawn from this pack are equal likely cases. Out of this 13, 2 to 10 are numerals, numeric numbers, natural numbers, positive integers. 9 cards, 9 into 4, 36 cards are belongs to numerics. What is chance of getting a card is drawn from the pack? What is chance of getting it is a numeric? 36 by the total cards, 4 into 13, that is 52 is the total card. You remember this point. Simple probability 36 by 50. According to random experiment, the sample space contains elementary events. The remaining 4 cards are, out of these 4 cards, 3 cards are face cards. Jack, Queen, King. The sequential order. Jack, Queen, King. Jack, Queen, King. Jack, Queen, King. Now this is black cards. Jack, Queen, Queen. I am using the same colors. For this case also. 2 to 10. All spade cards and club cards are black cards. Diamond and heart is red color cards. There are 26 red color cards and 26 black colors. By observing the color also, both are equal likely cases. These 2 are red color. These 2 are black color. The number of red is 26. The number of black is 26. Out of these 4 or 3 are face cards. Each suit, there are 3 cards, 3 into 4, 12 cards. Only one is remaining card. It is a special card. That is called ace card. Ace is called a premium card or special card. Ace, ace. 1 into 4. 4. Total is 52. No extra card. No joker, no extra card. Completely the pack contains 52 cards. This jack, J for jack, Q for queen, K for king. Jack is also known as knave. It's called a knave. Knave means soldier. 4 soldiers are there, 4 queens are there, 4 kings are there. All are equal likely cases. Jack, queen, king, ace are equally likely cases. Spade, diamond, heart, spade, club are equally likely cases. Remember these points. These points are very, very important. But here is 4 kings are different. 4 queens are different. 4 jocks are different. The soldiers, queens, kings are rulers of the Scotland, Ireland, United Kingdoms in the century of 3rd century to 13th century. One of the king is Julius Caesar. Out of these 4 kings, original pictures are there. One of the king is Julius Caesar. Remaining kings are Thomas, David, John, like this. For interesting of this one. For interesting of this pack here. But actually here, in the earlier situations, this concept based on this pack of cards, the Chevalier Demer and Pascal introduced these probability techniques. Apply the probability technique to solve the one problem. Problems on points. Nowadays here, help of the probability theory, how to win the games. Some techniques are there. What are the chances to win the game? Odds and odds in favor, odds against. Based on the probability theory, we can give the odds of winning chance and losing the chance. That is the importance of probability theory. 4 cards are drawn from the pack of playing cards. Now, help of this one here. Help of this one. That is 52 C4 ways. Total possible outcomes. Denoted by N of S. Here we have to use the combination. By selecting 4 cards. By drawing, selection, chosen, divisions, apply the combinations. In the application of probability theories, I will give the permutation and combination techniques. These are very important here. To construct the sample space, to write the sample space, help of the combination, help of the permutations. I will give the concept of the permutation also combinations in the next class. Now, here is one more remark. Jack, Queen, King are face cards, picture cards. Generally, technically, we have to speak here face cards. Ace, King, Queen, Jack are called honor cards. Honor cards. This is the complete description of the pack of cards. Another example here. Five cards are drawn from the pack of playing cards. One after the other, without replacement, but in this situation, this is a random experiment. Five cards are drawn from the pack of playing cards, one after the other, without replacement. Generally, five cards are drawn from the pack at a time. It is also called without replacement conditions. Here clearly mentioned in the examination point of view, five cards are drawn from the pack of playing cards, one after the other, without replacement, is given by what? In first drawing, you have to select one card here. Simultaneously, in the second drawing, the pack contains 51 cards. You can select one card here. Next one here, 50C1. Next one is 49C1. Next one is 48C1. Without replacement conditions, you can choose like this. But actually, it is a permutation concept. But in without replacement conditions, the outcomes are dependent. With replacement, outcomes are independent. So the situation is equal to 52 into 51 into 50 into 49 into 48. So this can be written as 52P5. 52P5. That is NPR. What is NPR? N factorial by n minus r factorial. N factorial by n minus r factorial. 52P5. 52 factorial by 52 minus 1, 47 factorial. By after cancellation, we get this one. You remember this point here. So now, five cards are drawn from the pack of playing cards. At a time here, the five cards are drawn from the pack of playing cards. At a time. The n of s is equal to, we also n of s. The previous case and present case. But actually there is no action in the next time here. Directly you have to choose the five cards from the pack. The examination point of view, the solvation of problems, you have to think about like that. You have to select five cards from this one. But in this case, you have to choose combinations. 52C5. Five cards are drawn directly from the pack. single time. There is no second option. By shuffling the cards, accidentally 5 cards are dropped. In this case also you have to use this 52C5. By shuffling the cards here, you have to draw the card by card. Attempt the 5 trials with replacement, without replacement. There are 2 options are there. Most of the cases without replacement is very important one here. 52C5, 52 factorial by 47 factorial into 5 factorial. Now here is 52 into 51 into 50 into 49 into 48 into 47 factorial by 47 factorial into 5 factorial is 120. These 2 cancel. The difference of these 2 here, we remember here. This is the result here. Don't simplify step by step here. After completion of this evaluation process, finally how to take the one simplification. Now remember this one here. But in this case, there is a order is important. With order. With order. Here is no order. In this case, no order. Remember these 2 points here. The problem with order is use permutations, without order use combinations. The 2 different techniques are X. These are very important for the examination. So some of the students are thinking in different way here. That is very problem. The numerator value dividing by 120 gives this. So combinations by selection process here. Without replacement. To apply this without replacement techniques. Suppose here, according to sample space, without replacement cases, permutation is used. For favorable cases also, you have to use permutation. To solve the problem using permutation only or solve the problem combination only, some problems can be solved by using both permutation combinations. In numerator, denominator, apply the same techniques. Sometimes you have to mix up with. I will give the clarity here. That is very important one. Attendees, any doubt regarding this examples? Today, many examples are given for illustrations or examples of sample space. These are important here. So now one more example. I am giving the one more example. That is the ninth illustration. A box has 3 red, 4 black, and 5 white balls. 3 balls are drawn from the box. By default, without replacement. But directly how to take the 3 balls from the box. The number of possible outcomes are here n of s. First of all, here total number of balls. Total number of balls is equal to 3 plus 4 plus 5. That is 12. Number of combinations number of selections or number of combinations. Number of selections or number of combinations. 12C, 3 balls are drawn at a time. 12C3, 12 into 11 into 10 by 3 factorial. This is short way, NC3 formula. N into n minus 1, n minus 2 by 3 factorial. Shortcut concept. Help of this one, replace n by 12. That is 12 into 11 into 10 by 6. 2 times cancel. That is 220. Possible cases are there. Number of combinations. Number of selections. 220 selections are there. Each selection contains 3 balls, 3 different colors. All 3 are red, all 3 are black, all 3 are white, may be possible. 1 red, 1 black, 1 white may be possible. 2 reds, 1 black is may be possible. 2 red, 1 white is may be possible. Different combinations are there. Only maximum extent is 220. Here, there is no order here. In this case, no order. Order is not considered. Suppose if order is considered, order is considered. In this case, n of s is equal to 12C1, but order is considered means here drawn 3 balls from the bag, from the box, one after the other, without replacement. Without replacement. With replacement is there, without replacement is there. So I am giving this here 12C1, 11C1, 10C1. That is equal to 12 into 11 into 10. Without replacement. Without replacement conditions. Lot of combinations are, lot of possibles are there. Based on the requirement, you can use. According to probability theory, don't bother about this situation. I am giving a simple technique. So now here is n of s with replacement 12C1, 12C1, 12C1. That is called 12Q with replacement condition. With replacement. Both are very important. So these are the examples here. You mainly concentrate situations here. You know, some you have an idea, you have a knowledge, 30% knowledge in the subject, but you have to refine. Only 5 to 10% to techniques are to be new. You have to practice it. But already you have some good knowledge in this subject. You have to improve that. You have to refine that knowledge. Order is considered. Here is no order case. Remember these 2 points. Dear students, any doubts regarding this one? Raise your hands. Any doubt regarding this one? Today class is now I will stop the class now here. Tomorrow I will take the class through the app here. Some technical issues are there. Definitely our team also rectify this problem. Tomorrow I will conduct the class through app here. So this session also recorded. I will send the video and upload the video in the video portal. So in the app, the video portal is there. So today I will upload this video portal after 1 hour. Now, thank you. Now session is over.